In this video, we're doing improper integrals with an infinity in both bounds. So in this case, what we need to do is we need to pick a convenient x value between negative infinity and positive infinity to split this thing up into two integrals. And usually the best one for that is choosing x is 0. So let's start off by rewriting this as negative infinity to 0 of x over 1 plus x squared dx plus the integral from 0 to positive infinity of x over 1 plus x squared dx. Now, in this case, as we take the limit, if either one of these diverges, then the entire problem diverges. Let's start with the left side and see what happens. So we have the limit as L approaches negative infinity, integral L to 0 of x over 1 plus x squared dx. Well, let's go ahead and integrate that over here for a moment. So I've got integral x over 1 plus x squared dx is a u sub. If u is 1 plus x squared, du is 2x dx. If I want to multiply by 2 on the inside, I have to divide by 2 on the outside. I now have 1/2 integral 1 over u du, which is natural log, or absolute value, 1 plus x squared. So now let's come back over here, and we've got the limit as L approaches negative infinity. We have the natural log of the absolute value, 1 plus x squared, from L to 0. If I plug in for that, I get natural log absolute value 1 plus 0 squared, which would just be the natural log of 1, which is 0, minus the natural log absolute value 1 plus L squared. Now remember, we're plugging in, we're going to negative infinity. So if I'm going to negative infinity, then this, because of that negative, is going to be negative infinity. This problem diverges, which many of them do. Let's do one more example. So again, let's pick a convenient x value. Again, I'm going to choose 0. So we're going to rewrite this as negative infinity to 0, 2 minus x to the 4th dx, plus 0 to positive infinity of 2 minus x to the 4th dx. Again, if either one of these diverges, the entire problem diverges. Start with the left side, limit as L approaches negative infinity. We're integrating from L to 0 of 2 minus x to the 4th dx. Well, that's a pretty basic integral to do. We've got the limit as L approaches negative infinity. Integrate 2, you get 2x. Integrate x to the 4th, you get x to the 5th over 5. And we're doing that from L to 0. So now we have the limit as L approaches negative infinity. If we plug in our 0 first, we're simply going to get 0, minus, if we plug in our L, we get 2L minus L to the 5th power over 5. Well, again, we're plugging in an infinity here. So when I plug in an infinity, I'm going to end up with negative infinity because of this negative, and again, it diverges.